Alright, so we have to sketch this function. And if you have a look at it, it's pretty easy to see the x-intercepts as is. So if I'm looking at this, I can see the x-intercepts as 0, and then from here I can see x would have to be plus or minus root 7. And because that's a 3, I can see these are going to be triple roots, these roots here. So so this would be the difference of two squares, and then if I do that, so I've got, I'll show you, root 7 minus x and root 7 plus x, but this is still cubed. So both of these brackets, or both of these roots, are triple roots. So remember, for a triple root, it's like a cubic. It looks like a cubic at that point. Alright, so that's handy to know. So I should have pre-done this, but it doesn't matter. Okay, so let's just do a rough. There's x, there's y. So I know that 0 is a root, root 7 is a root, minus root 7 is a root, and they're triple roots, both of those. And the other thing to notice is if I put a negative x in, this will be a negative x, but this will go back to x squared anyway. So you can see it's going to be an odd function. If you're not sure, just sub negative x in the whole thing. But yeah, we're going to have an odd function there. Oops. All right, so I know it's an odd function. That's helpful to remind myself it's an odd function. And let's have a look at y dash then. So if I do y dash using so this and then this, so u dash would be 1 times 7 minus x squared cubed plus, now differentiate the second instead, so we're going to have 3 bracket 7 minus x squared to the power of 2. We're trying to go inside the bracket chain rule, you've got minus 2x, and then we're timesing by the first, the u, which is x. So if I differentiate, if I factorize by 7 minus x squared squared, they've both got a squared in them. I've still got a 7 minus x squared in the first term, in this term. In the second term, I've got a minus 6x squared there. So I'm going to get a minus 7x squared. So I'm going to put a 7 out here as well. Alright, so this will now be 1 minus, instead of 7x squared, x squared. So you can see that's y dash, and if we find stationary points using where y dash equals 0, so you've got, I'll do it properly here, 7, so you've got difference of two squares here, so root 7 minus x, root 7 plus x squared, or I could just put the squares on each like that instead of doing the square brackets, and then 1 minus x, 1 plus x. So you could see that at both, so at x equals plus minus root 7 and plus minus 1 from that, we're getting stationary points. Now, we already know this is a triple root, so a triple root, and the other thing we can note is that we've got a negative power of 7 here, so it's going to start down here, and this is a triple root, so think of this as a cubic. Looks like a bit like a cubic, except my pictures are a bit dodgy. So we also know that y dash at this point is 0, so this is a horizontal point of inflection here. The same thing will happen here. We'll get a horizontal point of inflection. Okay, and I have trouble drawing these. Okay, and so horizontal point of inflection there, but 0 is a single root, so it must come up and back down to get to 0, and we know it's an odd function, so down and back up there. Oops, dodge. Alright, so we know that these occur at plus minus 1, so this must be 1 something, and this must be negative 1 something. Now when I put my 1 and my minus 1 into here, into x, 1 times 7 minus 1 is 6, 6 cubed is 216. Had that one recently, so this is minus 216 because it's an odd function. Alright, so we've got the curve going. So, I mean, you remember there's lots of different tools you can use. So up to you which tools you do end up using to get the curve. And then it says find the area. enclosed between the curve and the x-axis. So you can see this is and this, which we know those areas will be the same, but if I just find the integral between negative root 7 and root 7, I will get 0 because they'll cancel each other out. So I do want area, I don't want just the integral. So I'm going to do 2 lots of from 0 to root 7 instead. So that's root 7 of this integral, this function here instead. Now, excuse me, that's a bit of a weird one. So let's let u equal 7 minus x squared, because we can check that. du equals negative 2x dx. All right, that's nice because we've got that 2 there already. So let me just get rid of that and put it here. All right, we've already got that 2, but I also want a negative. So if I put a negative there, I'm going to put a negative here to balance it. So my a becomes negative, and that negative 2x dx becomes du. And then 7 minus x squared is u, so it's u cubed. Okay, now our limits, so they originally went from 0, so sub 0 in there for x and you get 7, and to root 7, sub root 7 into there and you get 0. Alright, so this is going to be the same as u4 on 4 when I factorize, when I integrate, and I'll make the minus, I'll use up the minus by swapping the limits. There we go, same thing. So sorry, I have to go over here. So I'm going to get 7 to the power of 4 on 4, which, using my calculator, minus 0 of course, is 625 units squared. Alright,